Hi everyone, this is Mrs. GA, and today we're going to talk about midsegments of triangles. So first let's talk about what a midpoint or a midsegment is. The midsegment is the segment that joins the midpoints of two sides of a triangle. So if you look over here at triangle ABC, if DE is a midpoint, we can show it by showing that AE is congruent to CE and AD is congruent to BD. So again, D is a midpoint, E is a midpoint, and the segment that joins them is called the midsegment. So the triangle midsegment theorem tells us that the midsegment of a triangle is parallel to the third side. We can show that like this. So it's always going to be parallel to the third side, and its length is going to be half the length of the third side. So that means that DE is 1/2 BC. So we can use this equation to help us find missing parts of different triangles. So let's look here at example 1. We have 3 different parts. So first, we need to know that all of these have midsegments, so it's assumed that these 3 segments are all midsegments. So again, we can show that by showing that they are actually midpoints. And for this first one, they ask us to find y. So we know that the midsegment is always half, exactly half of that third side. So we could say y equals 1/2 of 36. So y equals 18. So it's as easy as that. Here we are told that the length of this midsegment is 8. And we would like to find AB. So we can start with the equation ED equals 1/2 of AB. So my midsegment equals 1/2 of the third side. We can substitute what we know. We know ED is 8 equals 1/2 times the length of AB. And if we multiply both sides by 2, we get AB equals 16. And this one does have units, so it's in meters. And for the third one, we're asked to find x and y. So let's start by finding y. So again, we are told that this is a midsegment, which means that this is a midpoint. And we know midpoints create 2 congruent segments. So we can start with the equation that 4y equals 6 times y minus 1. And now we just need to solve for y. So I'm going to distribute 6. So we get 4y equals 6y minus 6. Here, maybe I will subtract 4y and add 6 to each side at the same time. So 6 equals 2y, so that means that y equals 3. Okay, now to find x, we can use our triangle midsegment theorem, and we know that our midsegment, which is in this case represented by the length x plus 4, is always half the length of your third side. So 1/2 times 4x minus 2. So again, here, the rest is just solving a linear equation, so I'm going to distribute. So remember, this is just saying 4x times 1 divided by 2. So that gives us 2x minus, this is 2 times 1 divided by 2, which is 1. Okay, so here let's subtract x from each side and then add 1. And we get x equals 5. Okay, so in example 2, all of these go along with this picture here, and we are told that UV is a midsegment and UW is also a midsegment. So we know the length of UV and we know the length of this entire side. ST is 10.2. So first they would like us to find SV. So first, since we know that UV is a midsegment, we know that V is a midpoint, which means there are 2 congruent parts. So we know that SV is going to be exactly 1/2 of ST, right? Because a midpoint cuts a segment perfectly in half. So if we substitute what we know that SV equals 1/2 of 10.2. So 1/2 times 10.2 is 5.1. So we know that actually both of these segments are 5.1. Okay, next they're asking us to find the length of UW, which is our midsegment. So remember, we know that the midsegment is always going to be half the length of the third leg, which in this case is ST. And then we can substitute what we know, which would be the length of ST, which that total length is 10.2. So we get that UW is also 5.1. All right, in part C, they're asking us to find the length of RT. So we want this entire length. So let's think of RT as the third side for the midsegment UV. So we can create the equation that UV, which again is the midsegment, is always going to be 1/2 the distance of our third side, which in this case is RT. So substitute what we know. We know that UV is 5.6 equals 1/2 of RT. So if we multiply both sides by 2, so multiply by 2, we get that RT is equal to 11.2. Okay, next we are asked to find the measure of angle UWT. So that would be this angle right here. So to find this angle, we can use that very first fact we learned about midsegments, and that's the fact that a midsegment is always going to be parallel to that third side. So for example, I know that UV is parallel to RT. So here you can see that we have two parallel lines cut by a transversal. So the relationship between these two angles, remember we called same side interior angles. And when you have two parallel lines that create same side interior angles, we know that those two angles are supplementary, which remember that means that they add up to 180 degrees. So we can create an equation that looks like this. We know that angle VUW plus angle UWT should equal 180. And again, the reason for that is that they are same side interior angles with two parallel lines cut by a transversal. We know that angle VUW is 41 degrees. So if we subtract 41 from each side, we've then found angle UWT, which is 139 degrees. Okay, last we are asked to find the measure of angle SVU. So now I'm going to use a different set of parallel lines. I'm going to use UW, which is a midsegment, and the third side, ST. So again, here we know that UW is parallel to ST because that's part of the definition of the triangle midsegment theorem. And then I see, oh look, I have two parallel lines cut by a transversal. I see that these two angles, we know that angle SVU and angle VUW, so SVU and VUW, we would call those alternate interior angles. And we know that when alternate interior angles are formed between two parallel lines, they should be congruent. So we know that angle SVU is congruent to angle VUW. We know that angle VUW is 41 degrees, so we know that angle SVU must also be 41 degrees. And there you have it. All right, that is all for today's video. Thank you so much for watching.